Yes, this is teacher Asembo, and today we shall be looking at how to shade the Venn diagram, that's the set problems. Now, both the one set problem, the two set problem, and also the three set problem. Now, when I say the one set problem, I mean, for example, if I'm only given, let's say, that shade set A. Okay, let's say shade set A. So of course, it has to be in the Venn diagram. Now, outside here is what we call the universal set or the set under discussion. Now, how do you shade, let's say, the set A? And how do you shade, let's say, the set A complement? Now, this is a one set problem. We are also going to look at a more challenging one. Let's say if you have now three sets or two sets at the same time. Now, I want us to go systematically now one by one and look at how do you shade now a one set problem. Okay. Now, shading Venn diagram. So this is our Venn diagram. We have a set A, and this one as our set A complement. Now, remember, set A complement. A complement means those are the members which are outside that set, but they are under discussion. So they are inside the universal set. So here we are supposed to present that universal set sign. Now, let's start by looking at this first one, one set problem. So say, shade this set, let's say this is our set A. So the required region of shading is on the inside here, like this. So that one is set A. Now, set A complement. Set A complement, we shade outside this set A. Those are the members of A complement. That one's a little bit inside. Let me remove that. Okay, it's a little bit inside. Set A complement is how we shade. We make sure that we shade everything that's outside. Now, A complement, those are members that are outside A, but they are under discussion or they are inside the universal set. They are in the universal set. Now, remember we said universal set, that's the set which is under discussion. Now, let's look at a two set problem. Okay, now I already wrote them down here for the purpose of simplifying now our work. Now, A union B. A union B. The first one here, this is A union B. This is A intersection B. This is A union B complement. Then A intersection B complement. This is a union of A complement and B complement. And then this is A complement and the intersection of B complement. Now, these two of them, they were discussed also under the De Morgan's law. You're going to realize that A complement union B complement is just the same as taking, just a minute. I pick my ink, this one will be visible now. A complement union B complement, just the same as taking a set A intersection set B and then complement. Okay, shall be able to try out those two and see the result of getting this one and this one are simply going to be the same. That's why I did not repeat those two of them. And then A complement intersection B complement. This is the same as taking A union B and then complement outside of it like that. You shall also be able to try to prove it and see if indeed you are going to get the same result. So the result of A complement intersection B complement is just the same as taking A union B complement. Okay, so we are not going to repeat these two of them. So we shall only be able to try and prove them. So the result of this one and this one are just going to be the same. And also this one and this one are simply also going to be the same. So if you shade this one or you shade this one, all of them are going to give you the same result. Now let's start the first one here. A union B. A union B. Let me use that one. A union B. Now remember union. Those are elements which are both in A. No, those are members with elements which are in A or in B. So I'm using the word or because we pick the element in A, we pick the element in B, we mix them in order. Okay, so I can be able to shade A. So A, and then also we can shade B. Let me shade B as I go this side. Shade the B. Now union is everything in A and everything in B. Put them together. So that one is A union B. Now A intersection B. A intersection B, we shade now, the required part will be the shared part, where the members are in both A and in B. So this is only required part. A intersection B. That's the only required part. Now remember, for A intersection B, we normally pick the members which are appearing both sides. They are in A and they're also in B. So that's why we normally shade the shared part of those two sets. Now, let's check this second one here, this third one, sorry. The third one, A union B complement. A union B complement. Now remember, the B complement is everything that is not in B. Everything that is not in B. So we can start by shading everything that is not in B first. Everything that is not in B first. Everything that is not in B first. This is a little bit long. Let me remove it here. Everything that is not in B first. So we have shaded everything that is not in B. And then A. A is this one. Let me use a different ink to bring out that difference. Okay. And then with B, with A, sorry, with A here. But at the end, we shall have shaded everywhere there. So it is only B which is going to remain unshaded. So we have shaded both the universal set and also the part of set A. So that one represents A union B complement. Now let's go to this one. Okay, this one is going to be a little bit tricky. So what do we do? For this case, we can draw it separately first, and then we see which part is appearing both sides. Now remember, for intersection of set, we normally pick that element that is both in A and in both in B complement. So for this case, let me add a little bit here so we can be able to have a space to draw separately. Then we join them here. Now I can come up with this one here. Let's say I want to only shade the set A. Now set A, if I shade set A, is going to be this set A, all of it. This is set A. Okay. Now I can also shade the B complement. The B complement. Now remember, this is set A and this is set B. This is set A and this is set B. Now, how do we shade B complement? Now, B complement are those parts that are not in B, but they're under discussion. They're universal sets. So let me use a different ink there. So I can be able to shade everything that is not in B, which is going to be the outside one here. Everything that is not in B is going to be outside one here. Everything that is not in B. Now let's check which part is appearing both sides. Now we can be able to see that the part which is appearing both sides is the one inside the A. Okay, so it is in A and in B complement. So the required part here, let me go back to my ink, this one here. So which means the both part which is appearing both sides is the one which is in A here, this side only, here only. So that is the only required part. Now, when it comes to intersection, you have to be very keen. Now, it's a little bit more challenging. You can do it outside the way I have done there. I first shade the set A, then you go ahead and shed the B complement. And then by inspection, look at them, which part is appearing both sides. You can be able to see this part here and this part here are both shaded, which means they are appearing in both sides. Now, let's move a little bit in the one I was talking about, the De Morgan's law, that he was trying to prove that this one and this one are they are the same. So A intersection B then complement. A intersection B then complement. So which means the one which is outside the shared part here, A intersection B complement, is the same as A complement union B complement. Okay, it's the same as A complement union B complement. Now, let's try this first one first here, and then we shall be able to see if indeed it's correct. I want to draw them down here. Let me have a large space here. Okay, for working space. Now, I will prove this first one, then we'll see if indeed the De Morgan law there holds. Okay, now since it's a law has already been proved to be true. It's only a theory or a principle that we can a little bit doubt. But since in mathematics, whenever we hear about the law, that one has been proved beyond doubt. That one has been proved beyond doubt. Now, let's start the first one. I'll draw the first one here. I'll draw first A complement. I'll first draw the A complement. So this is A complement. No, there is no need of putting their complement, just A. And then inside here, I put here as B. Now, let's start by shading A first, A complement. A complement is going to be the A complement. The A complement is going to be A complement everything that is not in A. So let me use a different thing here. Everything that is not in A, black one, okay here. Now, everything that is not in A, I'll shade everything that is not in A like that. Everything that is not in A is like that. Everything that is not in A, of course, going to touch up to here. Everything that is not in A. Now, let me present now B complement. Let's present now the B complement. Remember, it has to reach up here. Let's present the B complement. Now, this set A, and this is our set B. Now, the B complement is every member that's not in B. So we shade everything that is not in B. I'll have to use a different. Now, this time we use now the blue here. Okay, everything that is not in B. Everything that is not in B. Everything that is not in B. Everything that is not in B is this one. Everything that is not in B. Now you realize in both sides, there's one part which is not shaded. Okay, this one here. Let me use okay, this one will be able to shout out. Look at this region and look at that region. Both sides they are not shaded, which means there's no members appearing there. Okay, so what does that mean? It means that while we are shading, we can simply avoid the intersection A intersection B. So how do you shade it now? Okay, now let's shade it now. It means we shade everything but except the shared region, because both shared region is not being shaded here. So let me shade, and we avoid the shaded the shared part. Only the shared part is not going to be shaded up to here like this. So that one is our required region. Now we don't shade that shared part. We leave only the shared part. Now you have realized this De Morgan's law it's holding here. It means A complement union B complement is simply the same as taking A, then intersection B, and then complement. Intersection B complement. It will still give us the same result. This one, A complement union B complement, is just the same as taking A intersection B then, and then complement. Now, let's go this next one here. Also, the Morgan's law also holds that both of them are simply going to give us the same result. Let me clear this side so that I can be able to reuse here. Now, how do we present now A complement intersection B complement? A complement intersection B complement. Now, I told you when it comes to intersection, it's a good practice for you to draw it outside separately. And then you now check by inspection which parts are now appearing, both sides now. Let me first start by A complement. So A complement. So this is A, and this one is B. That's A, and this one is B. So let me start by presenting A complement. A complement is everything that is not in A. Okay, I'll use a different ink here. It's okay. Now, everything that is not in A. Everything that is not in A. Represent everything that is not in A. I'll shade everything that is not in A. That is A complement. A complement is everything that is not in A. And then the second one, I can again draw separately. Now this time now shading the B complement. So I can present the B complement outside here. So this is A and this is B. Okay, let me put here, this one is A complement. And then this one here is B complement. So how do you shade now the B complement? Let me take the different ink here. Now, the B complement. Now, B complement is everything that is not in B. Everything that is not in B. We shade everything that is not in B. Now, remember, intersection are those elements that are appearing both sides. So now let's check which region has been shaded. Which region has been shaded in both sides? Which region has been shaded in both sides? Now you realize it is only the outside one of both of them are being shaded. You realize that both of them are being shaded. So which part is left without being shaded? Which part is left without being shaded? Now you realize which one is now appearing both sides, sorry. Which one is appearing both sides? The one we have shaded here and the one we have shaded in the B complement. Now remember, intersection is a must to be in both set A complement and B complement. Okay, so that one means we are going to have only the outside. This one is not shaded and this side is shaded. So which means not appearing both sides. Okay, that means it's not appearing on both sides. So it means the required region is the outside one here. Only, it means only the outside one here. It is the shaded part. This only the required part here. Now, check for me this, the De Morgan's law. Now, it means it's simply the same as taking A union B complement. Just the same as taking A union B complement. So it is the same as saying that if you have A complement intersection B complement, it's just the same as taking A union B and then complement. A union B complement. Now let's look at the last one here on this. Let's look at the last one here on this series. Let me clear this one here. Let's look at the one now that the last part on a two-set problem. Let's look at that part on a two-set problem. Now, this one says we take A complement intersection B. Now, remember I said, when you are looking at intersection, you have to be more keen. The best practice is to draw them out separately and then check which part is appearing, which is appearing both sides. So let's start by A complement. Now, let's say this is set A and this one is set B. Now, which one is A complement? I'll pick my ink. A complement is everything that is not in set A. That one is A complement. Everything that is not in in set A. Now let's go ahead and present set B now. Go ahead and present set B now. Then we shade it. So this is set A and this is set B. So how will set B look like now? Set B, it is this one here inside it. And then we check which part is now appearing both sides. Which part is being shaded in both. So you realize it is these two parts which are being shaded in both. Now remember, intersection, it has to be in A complement and in B complement, appearing both sides. So we realize it's only this part which is appearing here and which is again shaded here. So our required part, we have found it. It is only this part. This part is only the required. This is the only required part for that two-set problem. For that two-set problem. Now, remember always when it comes to intersection, it's a good practice now to draw it separately and then check which part by inspection, which part is now reappearing both sides. Now, let's look at the three-set problem now. How do you shade the three-set problem? Now, a quick one, look at this one, A, union B, union C. Now, everybody knows union is everything that is in A, in B, and in C, combine all of them. So the required part is simply going to be this. Every member in A, B, and C. Okay. Now let's go this one. A intersection B intersection C. This one means the common region in three of them. The common region which is appearing in three of them, which is only there. Yeah, that's how it's been a quick one. Okay. Now let's check the next one here. Okay, it's a little bit now challenging. Now let's say we have A union B, then intersection C. A union B, then intersection C. Now, whenever you have an intersection, remember, it must be appearing both in A union B, then intersection C. A union B, then intersection C. Okay. Let's try to shade that one now. A union B, and then intersection C. Now, A union B will be all this one here. A union B will all this one here. A union B will all this one here. So let me draw it, then I'll wrap to take the required parts because I don't have enough space there. Now it means A union B is this one. A union B is this part. That one is A union B. That's A union B. And then which part is C? Which part is C? Now, the part of C, let me draw this one. Or you can do our practice like the other one in two sets. Draw them separately, then you check which one is appearing, both sides. Then the C1 is here. Okay, let me use a green one. You'll be able to shout out. The C1 is here. The C1 is here, like this. Now, what does it mean there? The only part which is being shaded in both cases is this one here. I'll use a red one. It means it is this part here. I'll shade using red. Then, so the only required part is here. This part here, which is appearing both sides. Okay. So let me rub now and then present it. It's okay. I'll just redraw it here. The three sets of them. Black one is okay. So this is A, this set B, and this set C. We have identified it that it was the middle one here, this one. That is what was appearing in both sides. Okay. Now it's always good practice. Remember the other side. We can always draw them separately and then we try to rejoin them. Now, let's go to this one. We now have A intersection B. A intersection B. Okay, I'll try out again. This time, let me use now yellow. Now, take A intersection B first. Where is A intersection B? A intersection B is this region here. That is A intersection B. Okay, and then union C. Then union C. Union C. Now, union C, let me use a different ink now here. And then union C. Union C. Now, remember, the members of C are this. Okay. Now, remember this one I said we try out first, then we check which one is appearing both sides. Okay. Be very keen which part is reappearing both sides. Now, do you see where where is blue and okay, that one yellow. Blue and yellow are meeting. That means the place we have shaded both of them. So the required part, okay, the required part is those three of them. The required part, let me draw the set A. Okay, now it means our required part was only this part here. The required part was only the middle part there. Okay, let me redraw it there. Let me redraw it there. So this one, and this one, and we have this one here. Okay, now we can as well draw them separately, and then we check which one is appearing in both sides. The intersection of this one and the C, it is this. It is this one here. That's the required region. That is the required region, which is appearing both. Oh, sorry, this is union and union. That is union. Sorry, it's not intersection. So we are making a mistake there. Okay, let's correct it. So it is A intersection B, then union of C. A intersection B, then union C. So everything. So A intersection B is this one. Okay. A intersection B is this one. And then union C. We just add the union C in this one. Yes. We were making there a mistake, which means we were not paying attention on the union. Union means every element that is in both sides. So that one is the required region where we are supposed to shade. Now let's look at the last one. The last one here. The last one here. Oh, preset. So it's only presenting us A complement and the union B. A complement and the union of B. Now you can draw it separately or you just pick it in the middle there. A complement, which means everything that is not in A, everything that is not in A, everything that is not in A. That one is everything that is not in A. That one's not in A. And then union B and B and B, which means it's going to be up to there. Okay, it's going to be up to there. Now, the same can happen when, okay, that is the three-set problem. Now, the same can happen when you are handling, let's say, when you are handling, let's say, the subset. Okay, if you have a subset in it, you have the subset in it, you still be able to represent the same. Now, you can be able to look at also the book 2, mathematics, and see some of the questions they have arranged there. Okay, now look at this one. Say this is A. Okay, this is the first example. A complement intersection B. A complement intersection B. So which is appearing both sides. Now remember our practice, you draw them outside first, and then you can be able to join them when it comes to the intersection. Okay, now you can be able to try out this question using the same methods and see. Now this is the subset I was saying, so it means B is a subset of A. So every element in B, they are also in A, which are represented inside here. We can also still be able to represent the same.